Today, our topic of discussion is blast furnace top gas volume. Top gas volume calculation is very important as almost all other modules of calculation based on the top gas volume calculation. Thus, precise and accurate calculation of top gas volume is must. Now, coming to our introduction slide, which is about a top gas volume definitions and all further description about top gas volume. So we can say that top gas volume is a fundamental output parameter in blast furnace operation. It represents the total gaseous effluent leaving the furnace leaving the furnace. Accurately determining the top gas volume is essential for estimating instantaneous production rates and understanding the furnace overall mass balance, especially focusing on carbon and hydrogen utilization. By monitoring top gas volume, operators can rapidly adjust the rate of injected fuel in response to changing a reduction condition within the blast furnace. Now coming to the our next slide, which is about nitrogen balance basis for top gas volume calculation. The calculation of top gas volume is primarily based on a nitrogen balance. Nitrogen is mostly inert and act as a tracer gas in the blast furnace. To begin, we calculate the total nitrogen input in kilomoles per minute. This comes mainly from three sources that we have to remember very well. One is the nitrogen in blast air determined by the blast rate and percentage of nitrogen in dry air, usually about 79%. Nitrogen from the coal injection based on the coal injection rate and the nitrogen content of coal, and nitrogen from other injection sources such as those used for pulverized coal injection or cooling. In most cases, nitrogen originating from coke is considered negligible. Now coming to our next slide, which is about determining nitrogen percentage and calculating top gas volume. So next we find we need to determine the percentage of nitrogen in the dry top gas. This is done by subtracting the measured volumetric percentage of carbon monoxide, carbon dioxide and hydrogen from 100%. So it is very simple. From 100% we have to subtract the three component carbon monoxide, carbon dioxide and hydrogen. Once we have percentage of nitrogen in the top gas, we can calculate the top gas volume very easily. The formula involves multiplying the total nitrogen input by the molar volume of 22.4 normal cubic meter per kilomole and dividing by the fractional percentage of nitrogen in the top gas. Now coming to our next slide, which is about key inputs and factors affecting top gas volume, and which is very important. There are several key factors that influence the top gas volume, and these include the blast air or wind, which is very important factor, the volume of air blown into furnace once and the rate at which fuel such as pulverized coal is injected, as these directly impact the gas volume, and chemical reaction occurring in furnace. Accurate measurement of top gas composition, specifically the percentage of carbon monoxide, carbon dioxide and hydrogen, are also vital. Lastly, oxygen enrichment affect the volume of inert nitrogen in the blast, thereby influencing the overall gas flow. Now coming to our next impact on iron making efficiency, then in this slide, understanding the top gas volume, especially in conjunction with its composition, allow us to calculate gas utilization rates. For example, the efficiency of carbon monoxide, denoted as eta CO, which is the ratio of carbon dioxide to the sum of carbon monoxide and carbon dioxide in the gas. An increase in this ratio means that less gas and consequently less coke needed to remove oxygen from the burden, which leads to higher furnace efficiency. These calculations are complex, and accurate determination and operational optimization typically require use of computer models.